Environmental impact assessment. Environmental impact assessment is a process that evaluates the potential environmental impacts of proposed project or development. Environmental physics play an important role in environmental impact assessment by providing scientific data and analysis to support the assessment of environmental impacts. The goals of environmental impact assessment is to identify potential environmental impacts of proposed project or development, assess the significance of these impacts and develop strategies to mitigate or avoid adverse impacts. The environmental impact assessment process typically involves several steps. Number 1, screening. This step involves determining whether a proposed project or development requires environmental impact assessment. The decision is based on criteria such as size, location, and potential environmental impacts of projects. Number 2, scoping. This step involves identifying the potential environmental impacts of the proposed project and determining the scope of assessment. The scope of assessment will depend on factors such as type of project, the location, and potential impacts. Number 3, environmental baseline study. This step involves collecting data on existing environmental conditions at the project site. This step is used to establish a baseline against which the potential baseline against impacts of proposed projects can be assessed. Number 4, impact assessment. This step involves evaluating the potential environmental impacts of the proposed project. Environmental physics can contribute to this step by providing data on air quality, water quality, noise pollution, and other environmental factors. Number 5, mitigation measures. This step involves developing strategies to mitigate or avoid the potential environmental impacts of proposed project. Environmental physics can contribute to this step by providing data and analysis to support the development of effective mitigation measures. Number 6, monitoring and follow-up. Step involves monitoring the implementation of mitigation measures and assessing the effectiveness of measures in mitigating environmental impacts. Environmental physics can contribute to this step by providing data on environmental conditions before and after implementation of mitigation measures. Environmental physics can contribute to environmental impact assessment process in several ways. Number 1, data collection. Environmental physics can provide data on environmental factors such as air quality, water quality, noise pollution, and radiation level. This data can be used to establish a baseline against which the potential environmental impacts can be assessed. Number 2, impact assessment. Environmental physics can contribute to assessment of potential environmental impacts by providing data and analysis on environmental factors such as air quality, water quality, and noise pollution. This data can be used to predict the potential impacts of proposed project on the environment. Number 3, mitigation measures. Environmental physics can contribute to the development of effective mitigation measures by providing data and analysis on the effectiveness of different strategies. For example, environmental physics can provide data on effectiveness of different types of pollution control technologies. Number 4, monitoring and follow-up. Environmental physics can contribute to the monitoring and follow-up of the mitigation measures by providing data on environmental conditions before and after implementation of measures. This data can be used to assess the effectiveness of mitigation measures and to identify areas for improvement. In summary, environmental physics play an important role in the environmental impact assessment process by providing scientific data and analysis to support assessment of potential environmental impacts. Environmental physics can contribute to data collection, impact assessment, the development of mitigation measures, and monitoring and follow-up. The goal of environmental impact assessment is to identify potential environmental impacts, assess their significance, and develop strategies to mitigate or avoid adverse impacts.